In this presentation, I am explaining about the rules of inferences which are being used for predicate calculus. So let's get started. These are the main contents we are discussing throughout this presentation. So first, what is predicate calculus? Predicate is a statement or properties that can be true or false. So, for example, x is greater than 5 or y is a prime number are predicates denoted by symbols like p of x or q of y. So, predicates is basically statements or properties that can be logically true or false that are generally called predicates. So, here this example, x is greater than 5, which is a true statement. Y is a prime number, which is also a true statement, whether like we are giving values to x and y respectively. So here p of x or q of y can be treated as a predicate statement. So quantifiers denote the scope of the variables in a statement. There are mainly two types of quantifiers. They are universal quantifier, which is represented by for every, and existential quantifier, which is represented that there exist. And variables are placeholders that represents elements. For examples, x and y are variables. So variables means the varying domain that can be represented by any letters x, y, p, q, r, etc. can be treated as a variables. So a predicate calculus is a formal system for representing relationships, properties, and quantified statements. It is also includes predicates, variables, quantifiers, and logical connectives. So all the parameters discussed previous slide can be included or integrated to make a predicate calculus. So here I have given an example. All men are mortals. Here m of x represents x is mortal and h of x represents x is man. So we can write predicate calculus as all men are mortal is for every x, h of x gives m of x. Here for every x, h of x means represents all men and m of x represents is mortal. And this is how a predicate calculus statement can be written by using the given statement or by given predicate. There are 6 rules: modus ponens, modus tollens, addition, simplification, distinctive syllogism, hypothetic syllogism. So let us consider all these rules and understand individually. First one is modus ponens, also known as law of detachment. The rule says if P and Q, P comes, the result should be in Q. The tautological representation is P gives Q and P implies Q. Modulus tollens, which is says the rule is P gives Q, and if not Q, then the result should be not P. The tautological representation is P given Q and not Q, which implies not Q. Hypothetical syllogism, which is also known as transitivity. So here P gives Q, Q gives R comes, then P gives R, which is a transitive relation between them, and tautology is P gives Q and Q gives R, therefore P gives R. Distinctive syllogism, P or Q, then not Q comes, then the result should be in Q. So P or Q and not Q implies Q, which is the tautological representation of distinctive syllogism. And addition, if P comes, then P or Q. Tautological representation is P implies P or Q. And simplification, P and Q comes, then result is in P. Therefore, tautological representation is P and Q implies Q. So these are the rules, or the 6 rules that are used to produce predicate calculus. Applications that are used by predicate calculuses are knowledge representation, rule-based system. Both of these are used in artificial intelligence and automated reasoning, mathematical logic, semantic representation also used in natural language processing by the help of predicate calculus, and expert systems, which are computer programs used for emulate human experts. So some of these applications works based on predicate calculus, and based on this predicate calculus rules, many logical propositional statements can be created. Thank you.